Science 7. We're making our way in a process of inquiry, which means that we're not following a line of development. Most education follows a line of development so that you could plot it point by point, so that you could test for it point by point. This experience shows that education cannot be tested. And the untestable education is the one that allows for maturation. The testable education that moves from point to point has a geometricity that is inculcated and depends exclusively on the refereeship of the mind to be certain, real, and acceptable. And life doesn't care about those criteria from that source. Outside of the range of all of the minds on this planet, the cosmos, for as far as anyone could believe, functions very beautifully. Though there seems to be the availability of understanding it in geometric terms, or even in metric terms, that is measurability, it allows for that on any scale and in many varieties to whatever exactness we want, and always offers unknowns for other possibilities. And what is measurable becomes a very small wedge of not a pie that's unmeasurable, but of a bakery that's unmeasurable. So the cosmos has a very interesting quality that is the substrate of substrates, and that is a natural mystery. Natural mystery. So that wisdom traditions, wherever they have arisen, on this planet or any other, always calm down the propensity to depend upon the mind as the arbiter of examination. And yet really deep wisdom educations must cultivate the mind and mature the mind as well. What the mind does best is to symbolize. Minds take experience and are able to take the flow of experience and deliver form that works within that experience as a shaping mode. And that shaping mode generally has the characteristic overall of integrating, so that the mind in its natural function is a part of nature. And symbols belong in the natural ecology. So that we saw in the first year of our education that nature, ritual, myth, and symbol are a four-part way, a quaternary, a quartering, of understanding how integration happens, how nature works, how nature behaves, and that a great deal of what we're interested in, and that we are, takes place within not just that scenario, but it's like a matrix. And that the path integral characterizes that matrix, and one of the strongest mental ideas in that matrix was geometry. The geometrizing of the mind, whenever it occurred, and it occurred several independent places on this planet, the most powerful of all of the applicable geometries occurred in classical Greece, more than in any other place. And in that classical Greek geometrizing, the most comprehensive teacher of that method was a man named Euclid. And Euclid lived about 300 BC. But Euclid was a Pythagorean. He was a member of the inner circle of the Pythagoreans, which meant that in his time, being about 250 years after Pythagoras, he was the inheritor of a very refined Pythagoreanism. The first 10 generations of Pythagoreans never wrote anything down except one, and that man, Archetyus, wrote 3 books that were available in the most limited edition imaginable, very expensive, very esoteric, in the sense that they were not only difficult to get a hold of, you had to have a very special way of getting hold of them, and not only were they expensive, they were almost impossible to read and understand without an uneducated mind, and the mind required you being a mathematician. One of the subscribers to Archetyus's 3 books on Pythagoreanism was Plato. And Plato's dialogues show increasingly his comprehension, his ability to understand the use of mathematics as a refining procedure for the mind within the philosophic enterprise of trying to understand by inquiry. There are some wonderful studies of this available. I'll bring next week one of the very best called Mathematics in the Platonic Academy, published just a few years ago. Also very expensive, very hard to find. Euclid lived in Alexandria, and he lived in an Alexandria which was serious about being a new kind of city, not a city that belonged to any particular population, not a city that grew out of folk traditions, but a city of cities, a city that grew out of a matrix of previous cities so that it would be a super city. It would be a cosmopolitan area. Instead of just a polis, like Athens was a polis, Alexandria was a superpolis. It was a cosmopolis, cosmopolitan. And so they needed an education that would allow for this stepping up, not just from peasant folk culture to urban civilization, but from urban civilization to a super urban civilization. And Alexandria was the first city to do that in the West. In the East, in China, the complement to Alexandria was Chang'an, and Chang'an had become a cosmopolitan center about 700 years before Alexandria was even founded. And the Chinese found a way, when they founded Chang'an, to understand their own kind of mathematic informing the process of philosophic inquiry, which meant a sophisticated, self-conscious education to allow for people not to shift from being peasants to being city people, but from being city people to being universal people at home everywhere. The founders of Chang'an in 1100 BC, who took over Chang'an at that era, used the I Ching in a completely new way to make sure that the Zhou dynasty capital was something completely new. And in the same way, the founders of Alexandria, the Hellenistic Greeks, used an educational technique that was founded upon the teaching of geometry. And the writer of that geometric text was Euclid. And so Euclid's Geometry, it's actually called the Elements of Geometry, was divided into 13 chapters so that one could move not from point to point so much, but from chapter to chapter, from matrix of understanding to matrix of understanding, so that you had the beginnings of an education that moved from one phase to another. And that the synthesizing path integral along that line, holding the phases together like the string holding a necklace together. The phases were like pearls being held together in a necklace by a string, and the string was the teaching of geometry, the geometrizing not of the mind, but of the education process by which the mind was brought into its form and its ability to absorb and apply method to its symbols, to its symbolic understanding. And they found that by doing this, as the Chinese had found in Chang'an 700 years before, that when you train the mind in this way, your integrals become very powerful. They are not just interesting ideas, but they become very deeply profound ideas, and their integrative capacity makes a tighter life pattern for those people. But when you turn to Euclid's Elements of Geometry, the very first sentence in the book is a definition of a point. And Euclid's classic definition of a point is very Pythagorean, very inner circle mathematiki, very mysterious. He defines a point as a locus of no dimension. Now, in the 20th century, there was a great mathematician named Weil, Hermann Weil, W-E-Y-L. And he said that a locus of zero curvature is a singularity, a singularity. And that this definition of a singularity has haunted the mathematicians like Stephen Hawking and Roger Penrose to this day. The difficulty of working that in is that for Hawking, he has assumed, along with a whole crowd of physicists who were dealing with quantum field theory, that in order to get away from being swamped with zeros and infinities and the incomprehensibilities that seem to follow in the train of these kinds of things, it's better to work with a Euclidean or Euclideized space. And that by doing that, one can come to certain understandings and theories, and one can talk quite intelligently and freely and make some advances. Roger Penrose questions that particular geometry and prefers a different geometry, not Euclid's geometry, but a geometry attributed to a man named Riemann. This is one of the early books on Riemannian geometry, published 1926 at Princeton. This used to belong to J.L. Barnes, the graduate school at Princeton, and he bought it in the 1920s. And you can find books, Graduate Texts in Mathematics, Riemann Surfaces, second edition. Or you can find very sophisticated books now published by Cambridge University Press in the Cambridge Tracts in Mathematics, the Riemann approach to integration. Riemann's geometry is different from Euclid's geometry. Euclid's geometry was based on a Pythagorean understanding of number, and that though number is mysterious in its origins, it is very definite in its development, because though the point of zero dimension is very difficult to appreciate, when you call a locus of no dimension a point, you have a beginning which now you can count on, literally. And so Pythagorean numbers and number theory in Euclidean geometry pay special attention to the development of 1, 2, 3, and the movement from points 1 to points 2 to points 3, and that this development is a line, and that with lines you can do all sorts of things. One of the things that you can do is that you can develop shapes out of lines that intersect at points, and this intersection at points of lines sharing the same plane makes the entire subject of Euclidean geometry called plane geometry. If you're in the 10th grade anywhere in the world, you get plane geometry. And the geometry text is some version of Euclid, still. Because that particular instruction is not something that one can improve on immediately on that level. It was done as good as you need to do it. But that if you get educated to that, if you get educated in Euclidean plane geometry, it develops your integral power of mind to the point to where you begin to glimpse that there's some other dimension that is now available because you've matured in this threshold, and beyond that threshold of comprehension of point and line to plane lies a realm that in our time, a very famous artist named Kandinsky said, this is the beginning, this is the threshold, this is the portal by which the mind matures to be able to first begin to appreciate art. And in fact, Kandinsky wrote a book called Point and Line to Plane, which was a sequel to a book we used in our art concerning the spiritual in art. And he wrote this book because he was teaching at the Bauhaus by this time in Germany. And he needed to teach students. And they needed to teach students art. And one of the things that get in the way is that the prosaic peasant culture mind origin did not allow for art to come out. All it allowed for is a kind of a puerile composition approximation, and so they wanted to have art, and so Kandinsky wrote this book in order to again bring back this power of concentration of the mind. Only this time, instead of doing it like Euclid, he did it like Kandinsky, that when the mind is able to understand that you can understand a plane of reference very, very well, the next step is a startling step which happened to Euclidean geometry and happens to Kandinsky geometry as well. And that next step is that you lift yourself off the plane into a sphere. And that this lifting off the plane into a sphere is very much like a poet who is able to write on a page and then lift the words off the page by reading it out loud or by reciting out loud. That the words no longer lie on a plane of geometric self-referencing, but acquire. The very first person to do this lived at the time of the I Ching, 700 years before Euclid. The first person to do this in the Greek experience was Homer, and he called such words winged words. That winged words no longer lie on the plane where lines move from dot to dot and meaning has its shape in terms of a plane of reference, but that the language acquires a poesis, a poetic quality, that they fly around, and you're not quite sure just where they're going to go, but they don't fly in straight lines ever. Sometimes they flutter, sometimes they soar. But what they do is that they occupy a sphericality. And it's only natural that once you understand the point and line to plane and reach the saturated limits of a geometry, that you begin to suspect that you could extend by a very curious expansion off the two-dimensional plane into a three-dimensional sphere. And instead of having geometry, you would have a trigonometry. And that the trigonometry of the sphere, which Kandinsky did not teach at the Bauhaus, but which was developed by a younger confrère of his named Max Ernst. And the spherical geometry of modern art was developed by Max Ernst. In geometry, in the Euclid sense that Stephen Hawking prefers to use, Roger Penrose prefers to have a trigonometric development into a sphere, a particular kind of a sphere, a Riemann sphere, a Riemann geometry, not a Euclidean geometry, but a Riemann geometry. And a Riemann geometry is different from a Euclidean in a very fundamental way. A Euclidean geometry is all based on number, 1, 2, 3, 4. Whereas a Riemann geometry is based on complex numbers. And that only by having a very high-powered integral mind capable of understanding symbols compact and dense enough on the level of complex numbers can you understand that a plane of complex numbers, when it is wrapped around a sphere, creates a Riemann surfaced sphere which now has very interesting mathematical properties that one can investigate an amazing array of extension of the powers of the mind, of the symbolic powers of the mind. One of the qualities of a Riemann sphere surface, though, is that it contains an infinite point. And when Penrose is trying to argue with Hawking's in our textbook, The Nature of Space and Time, he uses a complex number Riemann sphere with the south pole of the sphere as the infinite point. Literally, surprisingly, a Euclidean point of no dimension. And that as long as you unwrap that sphere into a plane, and you have a plane of complex numbers, that plane of complex numbers will have a coordinate system in 2 dimensions, the x and the y, and later we'll have the 3 dimensions, x, y, and z of the sphere. But on the plane, where it's just x and y, where the x and y coordinates of even that complex number plane, where they intersect, that intersection, that point, may be given a unit radius by which one draws a circle, and it can be of any length, it's just a unit. And that unit radius that draws that circle on that complex number plane, when that complex number plane is wrapped around a sphere, that circle will be the equator of that sphere, no matter what the numbers are. No matter what the relationships are, they will always hold that particular ratio, and thus it's a ratio of the real, as I like to say. But one of the things that's most important is that as Penrose is pointing out, in a complex number plane wrapped around a Riemann surface with an infinite locus on it, vis-a-vis that equator, equatorial cross-section through the sphere, one has the ability to analyze the entire possibilities and probabilities of that sphericality and come up with a certainty that is to any specification of exactness that you would require. And so the power of late 20th century mathematics, they delivered these lectures in 1994. The power of analytical capacity was almost infinite, but wasn't quite infinite. Because in order to allow for one to have the certainty of this game plan, you had to not ask questions about the center point of that sphere or about the infinite point on that sphere. Or if you took a certain kind of vector from that infinite point and let it go into a zero curvature mode, it would go off into infinity. And not to talk that way, not to use those cases. So if you left out the beginning and the end and the mysteriousness of the middle, then you had a very cogent story that you could argue about indefinitely on very high level, Cambridge University level. And that the peasants and the city people who are trying to follow these famous experts are oohing and aahing at how acrobatic all of this is. But if you're interstellar guide, they're rather in sandbox. And they're not going to go anywhere. Because you can't get off the planet with that kind of limitation. And you especially can't go interstellar with that kind of limited mind. Sorry. You're not going to be able to get winged wordedness. And you're not going to get out into the mystery where the cosmos really breathes deep. Deeper than lungs. Like the ancient Chinese used to say, there is such a thing as the billows of mystery where the Tao comes into the world and plays. On page 15 of this text, and the text is not a text, you understand, to learn as in an instruction mode. It's a juggling ball that the juggler sitting here is making a show. Not to dazzle you, but to show that these are not terrifying things, but they are merely jugglable balls of a game, an entertainment, and not to fear them, and that one can learn to do this as well, and that having learned that, to set them down and understand that you are real beyond any games, beyond this kind of sandbox playing. Complex though initially it sounds, it is very limited in terms of interstellar super civilization. Even in terms of a stellar civilization. Even in terms of just one star system wide civilization, you can't have it on this level of mind. Because you have to go beyond sphericality. You have to be able to go into infinities and zeros and unknowns all the time, at any time. And this is one of the things that Stephen Hawking says, if we allow for a singularity to be anything it wants to be at the beginning, that means that at any time, any singularity can be what it wants to be. And then what kind of laws are you going to have? And the Zen masters are laughing their asses off. And they're saying, that's what we found out. We stopped obeying laws. And we started just sweeping the dust and looking at the moon. And every time someone pointed at the moon, we cracked up. If you come to really sophisticated international, this is from Italy, published in Pisa, The Theory of Singularities and Its Applications. Very hush-hush, not because it's hidden from you, but because out in plain view, it is so complicated mathematically. It is so complicated in terms of modern astrophysical implications that you tremble. One would hardly even open it up. It's in a very profound gray flannel cover. Do you dare? It's like a Swiss secret portfolio. Just who are you? And yet, when you open it, you find high school geometric drawings that characterize the arguments. My God. And then you come to Cambridge lecture notes in physics. These are just boys. This boy is a very intelligent boy. C.J.S. Clark from the University of Southampton. This started the series in 1993. There are now, I think, 12 or 15 volumes. This is a $40 paperback. The analysis of space-time singularities. I'm trying to get you over the fear of the unknown because it's so complex. The conclusion, I turned all the way, it saved you 152 pages. This is not me. This is them. It is perhaps one of the disappointments of the subject of space-time singularities, as it was established by the definitive work of Hawking and Penrose in the early 1970s, that no final satisfactory statement emerges of what a singularity is really like. My goodness. Let's take a break. Let's come back. We're pursuing an education of inquiry rather than any instruction, or rather than any channeling or any metaphysics. And what this is a process of acquainting ourselves in such a way that our intuition participates in our intelligence. That is to say that vision mixes with symbols, so that the mind is not just an integrator, but is also a differentiator. And that differentiation being a completely different process from integration, has a peculiar quality when it comes into play. And the quality that differentiation has when it comes into play is that we have momentary not knowingness. Momentarily not knowing. It's the zeroness in complement to the oneness of knowing. An integral, no matter how complex it is, always literally comes to one thing. And if you were very good at integrating, you would integrate everything to that. The Chinese call that Te. Whereas Tao is not the other side of the coin of that, but is not on the coin. Because the integral contains both sides of the coin. Both what is sayable and what is not said are part of integration. What is unspeakable is in the Tao. No one can speak. And so one of the classic books you will find in most bibliographies of physics since it came out, Speakable and Unspeakable in Quantum Mechanics. And our education now is at the point where we're adding to our exploration of myths and symbols, of rituals, of nature, to our exploration of art, our exploration of visions, our exploration of history. We're adding science, but not just adding science in an integrable way, but because of its nature, science needs to be accepted in a differential mode. If you just add science, you're not doing science. You're doing a version of science which is integrable, and it generally belongs to a symbol-indexed phase, or occasionally just to a ritual-indexed phase. Or quite frequently, the language of science reduces itself to a mythic level. And you're just telling stories. When the mind plays games, the most that a narrative can come out to is an abstract, symbolic game. And usually, because one is not good enough at that, out comes a myth, a mythic story. And because this mythic story is not from the profundities of nature, not from the mysteriousness of nature, through the protean qualities of existence and the wonderful proliferation of existential actions that life is capable of. And so it doesn't have the nourishing richness of myth. Instead, it has come regressively back through the filter of a severely crimped mentality, so that these myths are truly lies. They don't have any relationship. They don't have any relationship primordially to the not knowingness that is a part of the mode of the way in which conscious vision happens. Our other book that we're using currently for the next week or so, along with The Nature of Space and Time by Hawking and Penrose. The other book is on Niels Bohr, Niels Bohr's Times, written by Abraham Pius, who was a Dutch physicist in between hiding from the Nazis in Second World War time Netherlands. He was studying physics, and when he got a chance, because he was studying quantum electrodynamics in the early 40s, he went to Copenhagen, where Niels Bohr was, where Bohr had a school and an institute. And Abraham Pius, the author of this book, became the first non-Danish student at Niels Bohr's school. And Bohr was very interested in him. And so Pius, because he was interested in Bohr, how did he survive all of this? What would a man of this enormous intelligence be like? How would he think? How would he do things? And so at the very beginning of his book, he records someone who observed Niels Bohr in one of the most characteristic primordial moods that the great nuclear physicist had. And here's how he described it. James Franck, colleague and friend of Bohr through many years, later had several experiences. When he would think about Bohr, he would think of the peculiar quality that the man had at certain times, and this is what he said. One thinks of Bohr when one had a discussion with him. Sometimes he was sitting there almost like an idiot. His face became empty. His limbs were hanging down. And you would not know this man could even see. You would think that he must be an idiot. There was absolutely no degree of life. Then suddenly, one would see a glow went up in him, a spark came, and then he would say, "Now I know. It is astonishing, this kind of concentration. This is a characteristic not of an idiot savant. Niels Bohr was one of the greatest thinkers of the 20th century, on level of Plato, on level of Pythagoras. We have to understand that when we are looking out at the world, our bifocal vision focuses. When we look with eyes inwardly, we tend to carry over that particular mode, that particular integral mode as a habit, and we look to see inner images, and that's how we see images in our mind. But the images that we see in our mind are the kind of mythic symbol integrals that offer themselves in imagination. And imagination in its yogic basis is purely integral. It is purely mental. It is purely an experiential image that comes and joins a picture which the mind frames. And the mind, in order to frame this, must use the physiological basis, which is limited. But when one looks the way Niels Bohr looked, he didn't look to see images in his mind. He didn't look with eyes that focused specifically on things. When he turned his seeing to look within, he saw nothing. He saw no images whatsoever. And so his eyes had a blankness to them because he was not seeing anything. He was not like the sleeping dog chasing the rabbit and his little legs are going because he's dreaming of chasing the rabbit. Niels Bohr looked within with inner seeing. He looked with it used to be called the singular eye of consciousness. Once in an interview, the old D.T. Suzuki, the old Zen master, was having an interview. It was filmed. He was interviewed by a very young Houston Smith. It was in the early 50s. And Houston Smith, very snappy, young philosophy professor, he had a yardstick, long stick called keisak that they use in Japanese zazen to discipline the people to keep meditating. And that if you start to drift, then they would whack you. But the whole thing that the Zen monks didn't understand is that drifting is a first kindergarten step in learning how to meditate in the high Dharma. But Japanese monks notoriously don't know that because they have a mental Zen. That's a Dharma, and you can make use of that. But in the high Dharma, like Chuangzi, in the 3rd century BC, he says, I have been flying north so long that now I will fly south. That there is such a thing as a great bird that flaps its wings once and soars 100,000 li. And all the other little birds say, that's impossible. We've lived our whole lives as birds and we can barely fly from bush to bush. But that Tao informed high Dharma is different from an inculcated, ritualistic monk zazen. Houston Smith entranced by the Casac, kind of like grinning like a mischievous philosophy professor. And I suppose, Dr. Suzuki, that when they drift, that they give you a whack for your own good. And he kind of a little quirky smile. And T.T. Suzuki, unfazed by the whole show, said, well, and as he turned his head, the glasses he wore reflected the Klieg lights from the filming, so that there were nothing but blurred glow eyes. He said, well, no. He said, that concerns consciousness. Consciousness is not a seeing of things, not a seeing of images, but instead of holding, the beholding. That the visionary beholding in consciousness is a presentation rather than a representation. It is a presentation of whatever is actually occurring and not a correspondent referent to what you know. And so if this state is sometimes called a not knowing state, it's not knowing as in ignorant, it's not knowing as in unspeakable, because it has no imagery whatsoever. And if it does, you're then on the feeding trough of a mental habituation that's geared to the external world, to the materia of the external world. And now, why is that bad? It's not so bad when you're dealing with just a limited external world. But the external world exists simply because of a polarization that creates form by tension. Literally, matter is an anxiety state of reality. That's how it stays where it is. And if matter didn't worry about its staying stable, it wouldn't be there. It would evaporate and vanish into the magical realms of jinn and all kinds of unicorns and everything else. And it would be a phantasmagoria, which is exactly what happens when you first learn to shift from looking out there at things that are very clear to looking in here and not looking at anything at all. And so the Vajrachedika, the Diamond Cutter Sutra, says at the very middle of its apex of going up step by step by step and down exactly step by step, in that balanced geometricity of steps at the very center, it says, awaken the mind by not letting it rest on anything. Because the mind that does not rest on anything must then use a winged word language to even speak. And this is that Homeric realm that we were talking about, of poiesis. Poiesis means to creatively make. And what is creatively made is a transposition. That in the integral realm, imagination now flies over in a pas de deux with memory. And imagination becomes creative in the differential realm, whereas memory becomes operative in the integral realm, so that you can remember exactly what the ritual steps are and how that got to be these symbols. Otherwise, there would be no way that you could operate. If memory weren't able to come into the integral realm, all you would have is the trust in habit, or what becomes even more pernicious, the belief in the mental plan. And you would cling to one or the other, or even best, when the two are brought into a tandem and someone says, this doctrine of inculcated action is best for you, learn it and don't forget it. That's not memory. That's habituation. It's actually a form of addiction. And so it acclimates you to being certain only when you're addicted. And of course, there are plenty of feeder systems that have their agents out there, and trillions are spent every year on this kind of foolishness, mostly in education. Excuse me. No one matures in that sequence at all. Not ever, not even once. Someone asked the historical Buddha one time, he said, in your vast, nirvana-wide Dharma mind, has anyone ever accidentally become enlightened? And his reply was, not even one. And he followed it up by a little homily that the monks repeat: work out your own salvation with diligence. That diligence is really the activity. Why? Because a diligence that is carried all the way through a path integral comes to the threshold where it is diligent about not being diligent anymore. And when you're diligent about not being diligent, you get to look like Niels Bohr. You sometimes look like you're not getting anything, because that is the mysterious, hidden moment where the artist gets his inspiration. There once was a man named Giesland, wonderful first name, Brewster Giesland. He was commissioned by the University of California Press to do a book on creativity. And so he interviewed and read up on all of the great creative people in last couple of 100 years of history. And he had 38 people that he chose. He had Mozart, and he had people like Carl Jung, and he had artists like Paul Klee, and he went through all of their descriptions of how they work. And he found that there was a characteristic loop in creative function, and that was after you have familiarized yourself with a method, with a pattern, with a materia base, and how to work with it, and you come to something you can't solve, a problem or a dead end in creativity, you let it go. And that what emerges out of that fallow interval is the solution, not in part but in whole. The whole thing is solved. The whole thing is there. Mozart, in his, one of his famous letters, said, I never write a note of a composition until I've heard the entire composition in my artistic imagination. And then when I write, I just transcribe because I know the complete piece. And so Mozart's compositions, when they're written down, his autograph compositions are remarkably clean. He didn't have to guess his way. He didn't have to go by any kind of pachinko game chance thing to get to Eine kleine Knack music. It was there and emerged whole, because in a differential field of openness, because the entire path integral is in the matrix of creativity, it emerges whole. And that's how nature works. Existence emerges whole out of nature, which is puzzling, especially in the 20th century, to people like Niels Bohr, because they were dealing with the subatomic world for the first time. No one had dealt with the subatomic world in quite this way. And this was all very new. We talked at the beginning of science of how the observation by a woman, she was a French woman, tremendously patient in her deep, profound regard for what was going on. She followed the action, and the action she was following was the curious behavior of an element that had just recently been isolated. The element was radium, and the activity was radioactivity. Her name was Marie Curie. And the measurement of radioactivity in Curie's is because of her. She was relentless. And because she was not unlovable in her relentlessness, her daughter also became one of the world's great physicists. And like her mother, worked with her husband at trying to open up to what is it that actually is happening, and how am I creatively seeing the wholeness of this in beholding it in my consciousness, in my artistic, personal consciousness. And very soon, after Marie Curie began to publish some of her writings on radioactivity, it occurred to a very sober, dour New Zealand Englishman named Ernest Rutherford, later on Sir Ernest Rutherford. And he wrote the first textbook on radioactivity in 1904. In 1904, they still had gas lights and horses in London. It is a almost 600-page textbook on radioactivity already. But it's just called radioactivity. Within 9 years, the book proliferated and now has a different title, Radioactive Substances and Their Radiations. In 9 years, by 1913, which is when Niels Bohr met Rutherford and began to work with him, to study with him, because Rutherford had something that Bohr understood. He had the Marie Curie patience to behold not just what he was seeing, but the entirety of the creative process, was able to work through the seeing and the not seeing at the same time. Later on, Rutherford wrote a final version just before he died, Radiations from Radioactive Substances, with James Chadwick and C.D. Ellis, published by Cambridge in the 1930s. And Chapter 1, Radioactive Transformations. And the first sentence, in studying the history of the rapid progress in our knowledge of atomic physics during the past 30 years, one cannot fail to be impressed with the outstanding importance of 3 fundamental discoveries which followed one another in rapid succession at the close of the century. We refer to the discovery of X-rays by Röntgen in 1895, the discovery of the radioactivity of uranium by Becquerel early in 1896, and the proof of the independent existence of the negative electron in 1897 by J.J. Thompson. And it was Thompson, in being able to behold the electron, that it was more primordial than the atom, that the electron was a particle, and that it was a curious particle in that it was a particle of negative electrical charge. That it actually existed, and that one could work with this, and that this was a very curious thing. In 1896, 1897, it was unheard of. One of the few people, one of the few human beings alive at that time who artistically got what was going on, not because he was looking over the shoulder of J.J. Thompson, but because he was very close to the creative, tuned, differential consciousness of J.J. Thompson. And his name was H.G. Wells, and he wrote a book called The Invisible Man. It's about a negative visible man in 1897. It came out at the same time, near the same place, because of attunability, because consciousness tunes. That's why there's a harmonic analysis of the differential cosmos that's available, mathematically, accessible to a consciousness which is expanded to that kind of a scale. One can tell, not because you're pointing at something, but because the entire array tunes. The resonances are there. That the alignments are not by lines. Even the word alignment is a habitual language. It's that the resonances begin to have a consonance, and they hum together. There literally is such a thing as a celestial choir. What does the book of Job say? There is a state of cosmic openness in God's realm where the morning stars sing together. They actually hum together. And that humming, we know now, takes place in something we understand as gravity, and that not only do planets have a gravitational choir with their star, but that there are many multiple stars, and that there are whole orchestras, not just of star systems that work together, but whole galactic clusters containing millions of them, and they sing together. They sing together because their harmonic energy gravitationally is in tune. Our galactic structure is a part of something that has about 25 different members, 2 really big ones and a lot of medium, little ones, and the entire ensemble is doing a do-si-do towards the Virgo supercluster that has so many galaxies you can't even count them. And it's true, it's 50 million light years away, but in a cosmos of 15 billion light years, it's pretty close still. And we can still hear those kinds of resonances if we have a differential consciousness that is scientifically tuned to that kind of a scale. Towards the end of his life, Rutherford, who was as dour-looking kind of Englishman as you would imagine, his last published book is called The Newer Alchemy, 1937. The Sedgwick Memorial Lecture delivered at Newnham College, Cambridge, November 1936. The Newer Alchemy. Because there was a different tone in Rutherford that Bohr was consonant with. He liked the alchemical side. He didn't like the purely mathematical side that Hawking and Penrose have a taste for. Have a taste for because they're very consonant with Einstein. Einstein had a taste for the theoretical math. He didn't like to get into the laboratory. He didn't build mechanical equipment to see what goes on. He thought in the creative way, opening himself to the Tao like Bohr, only he did it in his theoretic mathematics. He didn't look like an idiot savant. What he looked like was a junior patent clerk having coffee and a pipe sitting in a cafe in Switzerland. And all the time, all of this was just a patois of external veil beyond which Einstein was penetrating through and realizing that there has to be, in an integral ecology, there has to be a synthesizing symbol that actually does the action of bringing everything together, and Einstein found it. He was the first person in history to mathematically see it and bring it out. And he said, as early as 1905, he said, the synthesizing dynamic is carried by the photon, by the particle that carries light. that in the material universe, light is the indexing key. That's what it does. And no one saw a photon until 1923. Arthur Compton, someone who was able to isolate and show experimentally, yes, the photon as a particle exists, has properties. It has zero mass. It has lots of other zeros in it, but nevertheless, it is physiologically real, but can't be seen by sight. Can you imagine that the particle of light cannot be seen by sight? It's not just paradoxical, it's like a little Hasidic story. Stop looking to see how you look, because your looking in that way is blind. That one has to do an end run around your ignorant resistances of not wanting to see in any other way, because this works perfectly well. You can point to stuff you want and get it, and point to stuff you don't want and avoid it. What else do you need? Well, it turns out a great deal. A great deal. When Einstein saw the photon, in his theoria in Greek means contemplation. Theory meant contemplation. It meant a Pythagorean contemplation. There was no Greek word theory before Pythagoras. He was the first one. He found that theoria, contemplation, of clearing the mind of images and allowing for pure structural beholding to occur, that one saw in terms of music, of a harmony. And that when one saw in terms of a harmonic, you didn't pay attention to the notes. You heard, first of all, the sound that became music. That the noise of nature that had become sound through the integral refinement of ritual, myth, and symbol, how to transform where it became music. And a music that became tunable to a special key, and that there was a range of keys that when you saw the primordiality of the relationship, there were 8 keys in what he called an octave. Do, re, mi, fa, sol, la, ti, do. And once you know the octave of the musical keys, one is able then to creatively compose something that was never possible out of noise become sound, even become mythic rhythm. One was able to compose a kind of a music that came back and tuned nature. Our music tunes nature. Our conscious differential harmonic is so wonderfully absorbed and accepted by nature that nature welcomes it as something new. And we, like lovers, become one cooperatively together. A military commander in ancient Greece said, well, what good is this? And Pythagoras won a battle for him. He sent someone over to see how the horses of the opposition were trained, and then figured out the musical structure of that training ritual, and then composed a piece of music that reprogrammed that training. And he sent the opposition's horses into wild dancing, and they couldn't attack because the cavalry was ineffective. They lost the battle. It's good that conscious people like that are mostly peaceful. The bad guys don't know how close they come to oblivion. And that's only one guy. Wait till you get to the wise women. Because nature herself accepts tunability. Responds like a lover. So that while in integration, there is a constant trust in the way in which things come together in differentiation. The trust shifts to relationalities. And the relationalities are much more important than what you could grab, what you could hold. What you can behold is more important. Love is more important, by far, and carries its creative capacities into the integral, and it changes. By the time Einstein saw the photon theoretically in his contemplation in 1905, it began to occur more and more to people like Rutherford that we're dealing with a very mysterious threshold that apparently man is going to be able to go beyond. And that the work with Marie Curie, with radioactivity, was an indication of this. The work of Röntgen with X-rays was an indication of this. The development of the detection of the electron and now the theoretical positing of the photon meant that we now have a possibility of two subatomic particles, the electron and the photon, and they must have an interreaction, which they most certainly do, and it's a vast array that hasn't been explored yet completely. And added to this, of course, was the progressive development from 1911 till about 1919. While the First World War was grinding millions of men up, there was still an advance of the recognition that there are other fundamental particles, and that this whole arrangement of fundamental particles, if you ever get a chance to look at the particle explosion, Christine Sutton is one of the authors of this. At the back, she goes through what is called the particle zoo and arranges them together. And in this, you find the different families of particles, which are so wide now as to be able to include almost mystical things like the Higgs boson, which is just a condensation slightly of nothing whatsoever, and operates as an operator that allows existence to have polarization in the first place. But in this particle zoo, heading a whole group called baryons as the proton, and by 1919, the proton had been found. So that you had the electron, you had the proton, you had the theory of the photon, and suddenly in 1932, two other particles came cruising through together. One of them was a particle called the neutron, because it seemed to be like a proton that had no charge whatsoever. And the other was called the positron, because it seemed to be a negative energy particle that had a positive charge. So that you had a neutral, no-charge particle and a completely positive, negative particle that emerged in 1932 together. And all of a sudden, it was like the drawing back of the veil. Before the show came on, one realized that this stage was going to be something else. And by 1932, it occurred to people like Niels Bohr that the work that had been done experimentally was crucial, but that the experimental work needed not to be ritual work, nor mental planned work, but original, creative research into unknown actions, into unplanned symbolic gestalts. And how to do that was not known at that time and had to be played with. And that's where the lecture is next week.